Welcome to Simply Pi Maths.
In this video, let's learn the way to find probability of any given event. So the sum says, if two coins are tossed, find probability of following events. So first of all, I will start saying, since two coins are tossed, let's think of the sample space. What should be the sample space in this scenario? Two coins are tossed, right? So that means first can show head, second can show head, or first can show head, the other can show tail, or it can be the other way around, tail and head, or else both are showing me tail. These are the only possibilities, right? So I will say n of s is equals to how much? 4. Fine. Now let's think about this event. So this event says getting at least one head. So first of all, I will have to name this event. So I will say, let A be the event. Let A be the event of getting at least one head. Simple. And now I have to think of all the possibilities where there is at least one head. Okay, at least one head. So here you can see at least one head, here you can see at least one head, and here also there are two heads. So when we say at least one head, right? So at least one head means what? Minimum there should be one head. More than one head is also fine. That means this and this will be considered in this group. So it will contain all these three pairs. Okay, and now let's see how many elements are there inside this. N of A is 1 2 3, so it is 3. Now we have to find the probability of this event, right? That's what the main question was. Find the probability of following events. So this was first event of mine, which I have named it as A. That means I need to find the probability of this event A. So now let's try to understand how we will find the probability of this event A. So I will say probability of event A is nothing else but n of A upon n of S. Right, that's what the formula is. So in simple terms, probability of any event you want to find, what you have to do is write n of that event in the numerator and n of S in the denominator. This will always remain n of S. Okay, in order to find probability, the denominator should always be n of S, and the numerator will be nothing else but whatever event that you are planning to find the probability of, that event's n of A, like n of A or n of B, whatever the event is, you have to find the number of elements in that event and put it in the numerator. So in our case it is 3 and n of S is 4. So that is what the probability is. So I will just conclude the answer saying, therefore probability of A is 3 upon 4, and I will put it in the box. Simple as that. Let's see the next event that they wanted the probability of. So they want the probability of getting no heads. Probability of getting no heads, right? So let's write an event over here right away. We'll say, let B be the event. B be the event of getting no head. Okay, and let us see like what will be there in such an event. So when I say no head, which event contains no head out of these? This one, right? TT, this contains no head. Rest everything, every possibilities contains at least one head, right? So this is a possibility where there is no head coming up. So in this event I will just put TT, and n of B will be just one pair over here, right? So n of B is 1. Now I need to find the probability of B. So probability of B will be what? Same as we did over here, the same thing we have to do over here, but this time we have to do it for B. So what we will say, n of B upon n of S. As I said, this always will remain n of S. Here you have to put the events number of element in the event for which you have to find the probability. So now n of B is 1 and n of S was 4 earlier, so I will just put 4 over here. Therefore I have the probability of B with me, that is nothing else but 1 upon 4. Let's see how to handle this sum now. The sum says if two dice are rolled, find the probability of the following events. So there are some events given to us for which I need to find the probability. So first of all, I have to create a sample space, right? So it says two dice are rolled. So I will say since two dice are rolled, let's think about the sample space we have done in the previous classes also. So let's try to recall, whenever two dice are rolled, what might be the sample space looking like. You are right, it should be 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. And here, as we did the last time, make sure that 2 comma 1 start from the next line, 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4. So I have listed on all the possibilities over here, and as we all know, n of s in this case will be 36. Now let's jump into the very first event that they talk about. So the first event says sum of the digits on the upper face is at least 10. So what do you mean by at least 10? So it should be minimum of 10, or it can be anything more than that also, right? It can be 11, it can be 12, it can be 13, or anything. So sum of the digits is at least 10, so I need to look for 10. Then I need to check if we have 12 or 11 or 12 or 13. So that means sum of the digits should be minimum 10. So let's see, where is 10 now? So yeah, 5 plus 5 gives me 10, isn't it? 6 plus 4 plus 6 gives me 10, and 6 plus 4 also gives me 10. As we said, at least 10, so that means I can also look for 11. 11 means these two values will give me 11, isn't it? 6 and 5, 5 and 6, when we add them we get 11. And finally I can also check for 12. So 12, 6 plus 6 will give me 12. That is what the maximum that I can look for, right? So any other values if you add over here, it will give me something less than 10 only, and there will be no value which is more than 12 in this entire list. So at least 10 means I need to look for any value which is minimum of 10, and it can go up to any values, but considering 12 is the maximum that I can get over here, these are the only possibilities which we can shortlist, right? So I will say, first of all, I will have to name that event, right? That event, what was that event? Sum of the digits on the upper face is at least 10. So let me just say like this, let a be the event such that a be the event such that sum of digits on upper face is at least 10. Therefore a contains what all elements? All these elements, right? From 4 comma 6, 5 comma 5, 6 comma 4, 6 comma 5, 6 comma 5 comma 6, and 6 comma 6. So how many elements are there? 1 2 3 4 5 6. So I can say n of a is equal to 6, but they are moreover interested with the probability, isn't it? So what I will do is, therefore probability of a is equals to n of a upon n of s. So in this case I will have 6 in the numerator and what, 36 in the denominator. 6 ones are 6 6 are, so you can do the cancellation if it is possible. So what I am left with is 1 upon 6. That means probability of a is nothing else but 1 upon 6. Okay, now let's look for the event b. We'll say let b be the event. Let's look like what the event is now. So the second one says sum of the digits on the upper face is 33, but we saw, right, the maximum possibility is 12. 6 plus 6 is 12. So is getting 33 possible at the first place? I don't think so. Getting 33 is not possible. So what I will say, In this event there will contain no element, right? So B will be empty. But let's complete this. Let B be the event. What was that? Event such that sum of digits is 33. Considering we cannot get such a pair, so it will be empty. So therefore n of B will be 0. Again I need to find the probability, isn't it? So I will say therefore probability of B is equals to n of B upon n of S. That means 0 upon n of S was 36, and as we know 0 upon anything is 0. That means my probability of B in this case will turn out to be 0. Fine. Let's move on to the last event. Let C be the event. Let's see what is the event now. The digit on the first die is greater than the digit on the second die. Let me just write it over here at the first place. The event such that digit on first die is greater than digit on second die. Now let me see what all elements can come up. So what does it mean? First die's digit is greater than the second die's digit. First die is greater than second die. Can you help me in identifying such a combination? First die having a value greater than the second die. So if you just give it a check, you will get this number. This is a pair where first number is bigger than the next number. This is a pair where first number is bigger than the next number. So if you see, right, you will see a triangular format things, like these are all the pairs where the first number is bigger than the second number. Correct? Because if you go above this line, see, these are like the pairs where both the numbers are same, and above this all the pairs, the first number is smaller and the second number is bigger. So in our condition we need first number should be greater than second number. So these are all the possibilities which I should pick and drop it over there in set C. Let me do that. So I have made the list of all the possibilities out over here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 possibilities. So let me say therefore n of C is equals to 15. Okay, but that doesn't end our story, right? We need to find the probability. So what I will say, probability of C is equals to, as the formula says, n of C upon n of S. So let me write 15 in the numerator, and as we know n of S in this case was 36. If I do some cancellations over here, I can cancel with 3 stable, right? Or else I can I use any bigger number? 3 is the best. 3 5s are 15, 3 1s are 3, 3 2s are 6. So I am left with 5 and 12. So therefore probability of C will be 5 upon 12. Let's see the sum now. It's a sum of playing cards. So let me just write the solution like this. So first of all, let's understand what the sum says. A card drawn at a random from a pack of 52 playing cards. So I believe so you all know about playing cards. So a playing card contains 4 variety of cards in it. One is a card of hearts, and one set is for diamond, and the other set is for spades, something like this, and the other set is for club, which looks something like this. You might have all seen such cards, right? So now remember, in hearts we have a set of 13 cards, and in the same way diamond contains 13 cards, spade contains 13 cards, and club also contains 13 cards. Out of the 13 card, the first card is called as a ace card. and then we have few number card numbered from 2 to 10, and then we have 3 cards which are called as face cards. Okay, there are 3 set of cards called as face card. The first one is king, the other is queen, and the third one is jack. Okay, and this is there for all the 4 categories. Okay, so just keeping this in mind, let's try to answer these questions that we have in front of us. So first of all, I will say, since the pack contains 52 cards, therefore n of s is equals to 52. Okay, so in this case we cannot create a sample space and show, because it is not possible to create a sample space with all these cards details inside it. So the easiest way is just write the n of s directly as 52. Now let's see the first event that they are looking out for. They are looking out for an event where the card drawn is a ace card. So I will say, let A be the event of getting ace card. Means what? Therefore n of A, let's give it a thought. A contains how many such cards of ace? As I said, right, ace is one of the card in this list of 13 cards. So all these categories will have 13 cards. Ace will be inside all of them. That means we will have 4 such ace card, isn't it? So this answer will be 4. Therefore, in order to get the probability of A, what I will do, n of A upon n of S, that is nothing else but 4 upon 52. And I believe we can cancel these. 4 ones are 4, carry 1, 4 3s are 12, so the answer is 1 upon 13. Hence we have the probability of A with us. Therefore probability of A is equals to 1 upon 13. Now let's see what's the second event that they have. They are looking out for a spade card. So let me just name it as event B. So we'll say, let B be the event of getting spade card. Okay, so spade card means what? So as I said, right, spade is one of the categories inside it, isn't it? So we have 13 such cards of spade. So that means in this event we'll have 13 cards, right? So let's say like that. Therefore n of B is equals to 13. And simple as that. Now we'll find probability of B. Probability of B is nothing else but n of B upon n of S. So what do we have with us? N of B is 13 and n of S is 52. And this can be cancelled, right? 13 ones are 13 fours are. So therefore I will have the final answer as 1 upon 4. So I could write, therefore probability of B is nothing else but 1 upon 4.